Okay, welcome back to this lesson about compound interest. The idea of compound interest is you start with a certain amount of money, let's say $1,000. So this is your initial amount of money that we name like M0. M0 is $1,000. Okay, the time is in month. Let's say that the bank offers you the following business. It say, please keep your money in a saving deposit and we will give you 12% per year. But 12% per year means that they will give you 12 divided by 100 per year. But per month will be 12 divided by 100 divided by 12. In every month, they will give you 1% per month, or 0.01. So what will happen? You start with the initial amount of $1,000. You will maintain this amount of $1,000 during the month. So this is 1,000, 1,000. But exactly when 1 month happens, the bank will make you a deposit. What amount of deposit he will make you? He promised you 1% per month or 12% per year. 1% per month of 1,000 means $10. So he will deposit you $10, and now you will be with a certain amount that we name like M after 1 month. M1 is the amount after 1 month, and M1 will be $1,010. Now the following month will happen, and you will maintain the $1,010 or this amount, the $1,010, during the month between 1 and 2. Between the first month and the second month, you will maintain $1,010 deposit. But after the second month, the bank will give you the interest rate of the 1,010. So he will give you 1% of the 1,010. And 1% of the 1,010, it will mean 10.1. 10.1. So now the amount of money that is going to increase based on 1,010 is to add another $10.1. $10.1. And it happened again. Now this is M2. You will maintain $1,021 between month 2 and month 3. So this is your amount, and when you arrive to month 3, the bank will give you a certain interest rate of the 1,020. So you have 1,020.1, and he will give you the 1% of this amount. So he will add 10.20. So now it will arrive 10.20, and you will have, instead of $1,020, you will have $1,020.1 plus 10.20 will be $1,030.30. So you are getting money, and your money is being increased by the interest rate. And every time that you pass from 1 month to another month, you get more interest rate because the amount of money that is being deposited is bigger. Okay, so now we want to develop an equation, because imagine that they say to you, And what is the amount of money that you will have after 60 months? There is a general equation for this. So the general equation is being developed here and is what we call compound interest. So what we have said is that you start with a certain amount of money, M0, maybe 1,000, and 1 is the previous amount that you have at time t0 plus the change in the money. The change in the money is the money that you had multiplied by the interest rate, 0.01. So this expression can be written like M0 plus multiplied by 1 plus 0.01. Now it arrived the second month. M2, the amount that you will have at the second month, is the amount that you had at the previous month plus the change in your money. Now the amount that you had at the previous month is this amount, or this amount, M0 multiplied by 1 plus 0.01. And the change in the amount will be the amount that you had. You have M0 multiplied by 1 plus 0.01 multiplied by 0.01, that is the interest rate that you will earn because you made the deposit and you maintain the deposit for 1 month. So if you you see there is a common factor here, this one and this one. So M2 will be the common factor multiplied by 1 plus 0.01. Oh, I get an expression. M2 is M0 multiplied by 1 plus 0.01 squared. And now it's easy to prove that M3 will be, we recognize the pattern that is here, and it's easy to find that M3 will be M0 that multiply 1 plus 0.01 cube. Okay, M3 will be an M after n months will be M0 multiplied by 1 plus 0.01 raised to the power n month. After 10 months, it would be M of 10 will be the initial money, 1 plus you are earning 1% per month, multiplied to after 8 months, raised to the power 8. So in general, what is the equation in general? In general, you are getting money, you are getting an interest rate of R divided by N. This is the interest rate per month or per day. If you take the 12% per year and you divide into 365 days, you will have the interest per day. And the expression will be that M after n periods, maybe 12 months or maybe 365 days, will be the initial money multiplied by 1 plus the interest rate divided by n according to what you have decided to divide, raised to the power n. So now let's go to do the problem. The problem says, if you have $1,000 and you compound the $1,000 and they pay you 5%, after 30 years, how much will be in your account? So the 5% per year means 5% per year or 0.05 per year. Per month means 0.05 divided by 12, or 5 multiplied by 10 minus 2 divided by 12. So this is R divided by N. R divided by N is 0.05 divided by 12. Because it's being compounded, you deposit into that pays 5% interest rate for 30 years. Oh, so so it's compound per year, not per month. So I made the mistake. Oh, I'm sorry. Well, I did it per month. No. They ask you per month, monthly. So monthly, the interest rate is that you earn every month is 5 multiplied by 10 minus 2 divided by 12. So you start with the 1,000. This is your initial amount of money. Sorry that I called C0. I should have called M0. Sorry, is initial amount, quantity, the quantity of money that you have, the amount of money. So after 1 month, the amount of money that you will have is the previous amount that you had, the 1,000, plus the earning of interest. And the earning of interest is the 0.05 divided by 12, that is the interest rate per month multiplied by 1,000. So this will be again the equation for C2 is C1 plus what you earn. What you earn is based on what you had at the starting first month. You have C1, etc. So it's the same equation. So we will arrive to the equation that will say that C after 30 years, because a year have 12 months, after 30 years, 360 months has passed, so C of 360 will be the initial amount, 1, the interest rate that you earn per period, per month in this case, and it happens 360 months raised to the 360. So it will be C0, C, the amount of money that you will have, C after 365 months will be $1,000, 1 plus 0.05 divided by 12 raised to 360. And this, if you go to your calculator, will be around $4,467. So if you are patient, after 30 years, you can have $4,467. And now you may wonder, is worth it to wait 30 years not touching $1,000 to have after 30 years 4,467? Well, the answer depends on inflation during the 30 years and so on. So you can compare what has happened in the last 30 years in terms of inflation. For example, you can buy maybe a car. 30 years ago, you can buy a car for $4,000. And now this car will cost you 10 times, 40,000. So it's not worth it. It's not worth it because, yeah, it's more or less the same. You multiply by 4 the amount of money. You had 1,000 and you transform it in $4,000 after 30 years. With the car, you buy a car for 5,000 and now this car is maybe 50,000. So it's more or less the inflation, more or less. Well, I don't know. Now we go to this next subject, that is what happens if you compound continuously. This is a compound per month. If you compound per day, or per minute, or per second, or per instant of time, per nanosecond, if you compound continuously, what will be this equation? And this equation, it will appear the number E, and this is the second part of the video. Now let's go to the problem when the money is compound continuously. In the previous example, we have seen that the slope of the money in the first month is $10 in 1 month. In the second month, it was $10.10 divided by 1 month. In the third month, between the second and the third, the slope changed, and the slope was the rise 10.20 divided by the run. The run was 1 month. So the slope was changing. And the slope was changing according to the amount of money that you had. So we need to solve this equation now. What happens if the slope of your money is proportional, let's go to put an R, proportional to the amount of money that you have? What happens when the slope is proportional? When the slope is proportional and we need to start with a certain amount of money initially, and we want to know who is your money after some times t, we need to solve this equation. What is the function whose derivative is r by m of t? To solve this equation, we solve it like this. We make separation of variables. Means that we put all the variables that imply money in one side, and we put all the variables that imply time in the other side. Now we integrate the equation. We integrate the equation from a certain amount initial of money to the final amount of money. And we integrate the equation from the initial amount of money, maybe t equals 0 or maybe t equal at t0. When you have this money, it corresponds to this time, until the final time t, that is exactly the same time t that appear m of t. So what is the integral 1 divided by the function by the derivative of the function? This is a logarithm of m. The logarithm of m evaluate between m0 and m final. Maybe I should put a prime here to make, it's okay. And what is the integral to the right side? The integral to the right side is r by t minus t0, r by t. If t0 is 0, r by t. So what is this logarithm? Is the logarithm of m minus the logarithm of m0 equal r by t. But the logarithm of m is the logarithm of m divided by m0, r by t. So m divided by m0, I can solve it. If I put e to the logarithm of m divided by 0 equal e to the rt, e to the logarithm of m divided by m0, e raised to the power, e to the number logarithm m divided by m0 is the number m divided by m0. And this, it will be rt. So the m of t will be the m0 e to the rt. So in our problem, the m of 30 years, now is 30 years. 30 years is the amount of money that you start, the $1,000, multiplied by e raised to the power r. R is 5% per year. 5% per year, and I'm going to multiply by 30 years, r by t. You see, this exponent have no units. This is 5% per year. Multiply per year, have no units. So it will be 0.05 multiplied by 30 years. And this is the amount of money. It will be more than before. It will be more than the $4,400. I suppose that I think so, because you compound continuously. So you should arrive to a bigger number. What is this bigger number? Well, let me use the calculator and I will do it. If I use the calculator, the $1,000 is converted into 4,481.68 after 30 years. If I compound the money not continuously like here, if I compound the money per month, the amount of money was 4,400 something. Let me check. Yes, it was 4,467. Okay, it's a little bit more money. It's a big change. So let me represent the curve. The e to the rt. This is the money. This is the money. The money m of t. You start at m0. You start growing up with a slope here. The slope is the slope at t equals 0. And the slope at t equals 0 is the derivative of m respect to the t evaluated at t equals 0. And what is the derivative of m respect to the t? The function m is m0 e to the rt. And the derivative is r m0 e to the rt. So at t equals 0, e to the rt is 1. So it will be r by m0 is the initial slope. When I do the same slope from r equal 1, 1 year, the slope has changed because the slope is bigger, is r by m0 by the r and the m0 have not changed, but now it will appear the term the derivative of m when t equal 1 year, the slope at 1 year, it will be r by m0 by e to the r by 1. So e to the r is e to the 1. E to the r is e to the 0.05. And e to the 0.05 is bigger than 1, so the slope is bigger at 1 year. And how it will do the graph? The graph will do like this. And the slope is changing. Let's go to make it nicer, nicer, let's go to make it nicer. You start at m0, with a smaller slope, but with a slope, otherwise you will not grow, and you grow up exponentially. After 1 year, after 2 years, now the slope is bigger. It's bigger in this proportion. It's changed. Okay, but doing like this, you don't see the number e. We should see this number e to come to appear from the initial approach of compound interest. We need to see how the e appear from this equation. C sub n is c sub 0 multiplied by 1 plus r divided by n raised to the power n. Where is the number e here? This is the next part that I would like if you see it. Okay, in this part we want to see how the number e appear in a natural way. Maybe This is why natural logarithms is the word. Okay. What we know is the number e is 2.7.1 is an irrational number. It has many, many, many digits, infinity digits. The number e is defined as the limit when x tends to infinity of 1 plus 1 divided by x raised to x. So if you plug in a number, let's say x equal 1 million, it will be 1 plus 1 divided by 1 million is 1 divided by 1 million is 0.00001. So 1 plus 10 minus 6 raised to the power 1 million or raised to 10 to the 6. This will be 2.7.1. And when x tends to infinity, it makes an asymptote. This is the graph of the function f of x 1 plus 1. This is the graph of the function f of x equal 1 plus 1 divided by x raised to the power x. When x tends to infinity, the limit tends to 2.71. This is the asymptote, 2.71. And when x tends to minus infinity, the limit goes to 0. It's not symmetrical. Okay. Of course, at the point 0 is not defined because x equals 0. You cannot divide by 0. So this is the limit when x, this is e is 2.7.1, etc. It's an irrational number, and we want to see from this expression how the number e will appear, from the expression of compound interest. So let's go to do it. Let's go to manipulate this expression, the expression of compound interest, to see how we can make to appear the number e. So this is the expression that we see for compound interest. The money that you have, if you divide after 1 year, the R is the 8% per year, and N is the number of subdivisions that you make in the year. Maybe 12, maybe 360, so you divide the year in 360, so it will be per day, or maybe per hour, maybe per second. So we want to find when we divide R divided by N, when we divide in infinity parts. So we have the year, and we start dividing in 12 parts, 1, 2, 3, 4, 5. So in each part, the amount that you will earn, it will be proportional to R divided by 12. So we want to divide N in infinity parts. So this is the year, and we divide the year in infinity parts. So in every part, your money grows up like R divided by N. R divided by N, and this is the equation that we will have. So C sub N will be C sub 0 plus 1 divide R divided by N is the same thing that 1 divided by N divided by R. And N is the same thing that N by 1. So I have made a manipulation of this expression to write in a particular way that will allow me to see what is the number e. So C sub N will be C sub 0, 1 divided by N divided by R, which is R divided by N, is the same thing, N divided by R and R. And see what happens. Name N divided by R U. So the expression would say C equals C0, C sub N, C after N in periods, so C after 1 year, will be 1 plus 1 divided by U, raised to the power U, raised to the R. And what is that? In the limit when n tends to infinity, r divided by n tends to 0. So what is 1 plus 1 divided by u when u tends to infinity? U is n divided by r. So u tends to infinity. So this is the same limits as the number e. So c after 1 year, c sub n, c after 1 year is c0 multiplied by the limit of e to the r. Wow! So the number e appears. So c of t will be C0, the amount of money that you will have in the time will be C0 R by T. Whereas if R is per years, T have to be in years. Okay, so this is the expression, and this way the number E appears.